When we create such a large project as NICA, and this is truly a world-class project with several thousand scientists and engineers from more than 25 countries involved, about 100 leading scientific centers and manufacturing enterprises participate in its construction. All these immense intellectual and technological resources will, of course, enrich the baggage of human knowledge. Not only will they produce very important results for fundamental science, but they will undoubtedly provide the results that our society will be able to understand, applicable results. Any major project at the scale of the NICA Collider gives a tremendous push to the development of new technologies in material science, medicine, energy, industry, and computer sciences. We call it applied research at a large scientific complex. We work with thin films. This is graphene, films of superconductors. We develop and create intelligent electronic systems capable of recognizing images and trajectories accurate to picoseconds and femtometers. Together with the high-tech industry, we create products that can endure pressure drops of up to 12 atmospheres. The most serious requirements, as you have already understood from the experimental conditions, are imposed on computers. We need to recognize events with great accuracy and to store and be able to process immense amounts of data in order to observe and investigate online what is happening at the point of interaction. Therefore, talking about the development of computer technologies, we are now creating a new, unique computer center for NICA. We call it heterogeneous because it will use both cloud technologies, high-performance processors, and high-speed data transmission channels. And finally, there are two more very interesting things concerning the results of accelerator physics and technology development. People invented a unique instrument, accelerator of charged particles. With the help of this device, we can accelerate particle beams and use them as a scalpel that penetrates to a certain depth and with a high degree of localization, up to fractions of a millimeter, can remove ill cells in the human body without damaging the surrounding healthy tissues. As you know, in outer space, both the astronaut and the spacecraft are exposed to the effects of cosmic radiation. Cosmic radiation is a spectrum of different types of particles, including heavy ions in a wide range of energies. Cosmic rays of high energies and charged particles can cause failures in electronic components of a spacecraft, processors that control its movement. In addition, they have a harmful effect on the living things aboard. It can be manifested in disorders of the human sensory organs and higher nervous activity. Therefore, when we talk about long expeditions to Mars or Venus that last for 3 or 4 years, we must be sure that both the spacecraft and the astronaut will successfully fulfill their mission, return to the Earth with new information about these planets. While astronauts are in space, the radiation load is accumulated during all these long years of expeditions. Here on the Earth, by using beams of charged heavy ions from the accelerator, we can, literally within a few seconds or minutes, simulate the effects of cosmic radiation on living organisms and electronics, and thereby offer new methods of protection, new materials for the spacecraft's skin, new pharmaceutics that would allow us to very quickly regenerate the failures in the astronaut's body caused by cosmic radiation. All these studies related to radiation medicine, space, new materials, new types of electronics, all this will be made here at the NICA Collider.